Hello, welcome in my chemical education video lecture series. In this video, we are going to see the experimental part. It is related to pH metric application. Determination of the pKa of the weak acid with the help of pH metric titration. The title of the experiment is to determine pKa value of given weak acid by pH metric with a strong base. We know that the weak acid, for example acetic acid, dissociate into the acetate ion plus hydrogen ion, and by equilibrium constant, the concentration of acetate ion into hydrogen ion divided by concentration of acetic acid. A very small quantity of the acetic acid get dissociate into the water. Now at half neutralization point, the concentration of acetic acid is exactly equal to the concentration of acetate ion or concentration of hydrogen ion, and therefore Ka is equal to hydrogen ion concentration at half neutralization stage. And therefore from this we can calculate the pKa value of given acid as the pH of the solution at a half neutralization point. In this experiment, we required the pH meter. With this pH meter, the glass electrode. If it is a simple glass electrode, then we required the calomel electrode also. Or if we use the combined electrode, then it is a single electrode. We can use the pH pen also, the magnetic needle, then glasswares, burette, graduated pipette, the buffer solution that is a pH 4, or it may be a 0.05 molar potassium hydrogen phthalate solution, then 0.1 molar acetic acid solution, and 0.5 mole normal the NaOH solution. Now this is a requirement for this experiment. Now for this experiment, the first part of the procedure is the standardization of pH meter. Now this is the pH meter, and on this pH meter we see the knobs related to the temperature, maintenance, and adjustment of the value. Now this is the combined glass electrode, and this combined glass electrode kept into the solution where the potassium hydrogen phthalate of pH 4 is kept. Now before the starting the experiment, we have to start this instrument for 15 minutes to warm up period. Now after that, when you keep or dip the combined glass electrode into the solution of potassium hydrogen phthalate, it is observed that on this display card, the reading of the pH is get displayed. If it is 4, then it is okay. Otherwise, if it is a less than or greater than 4, then with the help of this knob, we can adjust this exactly equal to 4. Now, when it is displayed 4, then we know we are saying that the pH meter is a standardized pH meter. Okay. Now, in this way, the first part of the procedure. The second part of the procedure is related to the experiment. Now, the second part, the measurement of pH by addition of NaOH. Now, in this solution, we are in the beaker, we are taking the 20 ml of acid plus 30 ml of water into this flask, and then we have to adjust or dip the combined glass electrode into the solution, and from the burette we are adding the 0.5 normal NaOH solution. Now when we are starting the experiment, that is only acid is present, then we observe that the readings are 2.43. This is the pH for acid mixture of acid and water. And as we go on increasing the addition of 0.3 ml interval or volume interval, then we have to stir it, and then we have to measure the pH of the solution. Now this pH we have to write into the observation table. Initially at 0 stage, 0 addition, we observed that 2.43 pH, and as we go on increasing or adding the NaOH solution from the burette, the NaOH get interact with the acid, that is H plus, and the concentration of hydrogen ion go on decreases, and therefore as decrease in the concentration of hydrogen ion, the pH of the solution is go on increases, and it is observed that at 0 ml addition 2.43 pH, when you add the 0.3 ml of NaOH solution, then it is observed that the pH is increases from 2.43 to 3.34. Then as we increase the further addition of the 0.3 ml, the pH of the solution is increases. For further, we observe that 3.90. Now, as we go on continuing adding, we get the measurement of the pH. But in the observation table, delta pH, delta V, delta pH by delta V, and mean V. From this observation, from these four observation, we can calculate here the delta pH is the difference between these two values of the pH. We have to write here. The delta V value, from this volume, we have to take the difference between these two value and keep here. We know that every time we are adding the 0.3 ml, and therefore difference is same as a 0.3 ml. And therefore delta pH upon delta V, this value is this upon this equal to the 3.033. In the same way, we have to calculate the values. And lastly, mean value of volume. Now, mean value addition of this divided by 2. In the same way, addition of this divided by 2, then we have to write here. In this way, observation table we can write here by measuring the pH. Now here, this is the observation table, complete observation table for addition of 0.5 normal NaOH solution from the burette, continue addition of the 0.3, 0.3, 0.3 addition, and we are measuring the pH of the solution, and it is observed that these are the pH values from the instrument. Now then we have to calculate all these values and we have to write in the observation table. After writing, we have to plot the graph of delta pH divided by delta V versus the mean value of the V. And it is observed that initially slow increase is observed, and after certain time it gives the increase in the value of the delta pH by delta V, and again decreases, and we get the peak. Now this peak, the center point, highest point, is observed that this is nearly equal to the 3.9 ml addition, and this is the equivalence point of the titration. Now this equivalence point, as we are saying that it is a X, and half neutralization we can calculate 3.9 divided by 2 is equal to 1.92. Then again we have to plot the second graph, the pH versus added ml of NaOH. Now as we plot this graph, it is a S-shaped graph. It is a slightly increases because we are adding the base into the acid, get neutralized, and after neutralization point, the sudden increase is observed in the pH and then again remain constant. At this stage, the value of X equal to 3.9, and from this divided by 2, that is a half neutralization point 1.92. From the 1.92 value, we have to extrapolate this line and transfer here the pH of the solution at the half neutralization point, and it is observed that it is a pH equal to the 4.4, and this is the pKa value of the weak acid. From that value, we can calculate the Ka value equal to the anti-log of minus pKa, and this is equal to 3.981 into 10 raised to minus 5. This is the value of Ka. Now equivalence point of titration is 3.9 ml. pKa value of the monobasic weak acid is 4.4, and dissociation constant, that is Ka of acid, is equal to 3.981 and into 10 raised to minus 5. Now this is the experiment where pH metric titration or a application to determination of dissociation constant of weak acid. Thank you. If you like this, then you can subscribe the channel. Thank you.